Hello and welcome to another homework help video, and this is for the other half of the trigonometry exercise 3.1a. I think in the last video I said it was 6.1a, but you know what I meant. So this is the homework that Mr. Edward set you, and we're going to start with this kind of question. So it tells you what sine theta equals. Actually, no, it doesn't. In yours, it tells you what cos theta equals, but I guess I'm just trying to make it a little bit different, just so that I'm not just telling you exactly how to do it. But it's not going to make much difference, to be honest. Okay, and we want to find cos theta and tan theta, given that theta is acute. Okay, so we take this, and to make this in terms of cos instead, we can use the fact that sine squared plus cos squared equals 1, identically equals 1, which can be rearranged to say that sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared. So these two are very useful. So to do that, though, I'm going to need to square this, because at the moment it's sine, and I can't do anything with sine. So I'm going to square both sides of the equation. 24 squared, 400, 560, 576. You know, I've got a calculator literally right next to me. That's correct. Woo! Okay. So then I know that sine squared is equal to 1 minus cos squared, so I'm going to change that into 1 minus cos squared. And then, alright, I'll add cos squared to both sides, and I'll take away this from both sides, so that I end up with that. Okay. 576 take away 49. 527. I'm such a melon. I think I was supposed to put 25 here. I was definitely supposed to put 25 here. What's 25 squared again? 65. So, sorry about this. If I do this, it will work out with nice numbers. Such a melon. Oh, what's 65 take away 49? 576. Oh, look at that. Okay, and then you square root both sides. And we don't have to worry about plus or minus. Normally we would when you square root something, but because we squared it in the first place, we're just like undoing that squaring, and seeing as we know it was positive before, we don't have to worry about the fact that it could be negative. Square root of 576 is 24. Square root of 65 is 25. So cos theta is 24 out of 25. Sorry, I messed up the numbers. I tried to be clever and pick numbers that would work nicely, and then I messed it up. Okay, so that's what cos theta is. So tan theta, well, we can use the identity that tan theta is sine theta over cos theta. And I know what sine theta is, because they told me. And I know what cos theta is, because I just worked it out. So I can just divide them. Now, in reality, this isn't actually the method I would use at all to solve this kind of question, but the question specifically said use this identity and use this identity, so I did what they told me to do. Let me just, I'm sorry if this, this might annoy you, because I'm going to give you another method that the textbook doesn't approve of, but this method is so much better. You know what, you can skip this if you're not interested. But what I would do is I would say I've got a right angled triangle. They've told me that sine theta is 7 over 25. Well, I happen to know that sine theta is the opposite over the hypotenuse. So the opposite is 7 and the hypotenuse is 25. Of course, it might not exactly be that. It might be like 14 over 50. That's equivalent, yeah? But it's a similar triangle, which means the angles are the same. Okay, and then I can work out what the A is by using Pythagoras. I can just do 25 squared minus 7 squared, which is 576, which is actually like exactly what we did here. And then I square root that, which is 24. And then, of course, cos theta is the adjacent over the hypotenuse, so that's 24 over 25. So that's another way of working it out. And then tan theta is the opposite over the adjacent, so it's 7 over 24. So, I mean, it is the same, but instead of it being algebraic, it's geometric. And I just prefer that in this case. I just think it's a bit nicer. But anyway, you're supposed to use that method. So, next type of question. What have we got? Solving some... Actually, let's do simplifying first. Simplify. Okay, here's one. Cos squared x, tan squared x. Simplify this. Okay. Right, well I could change the cos squared into 1 minus sine squared if I wanted. So that's a possibility. I can change the tan squared into sine squared over cos squared. So maybe I will do that. Oh. And then they're just going to cancel out. Yeah, there's a times there. So the answer is just sine squared. And that's as simple as you can make it, really. Okay, let's try another one. This is tan x cos cubed x. Okay, if we simplify that, let's see. Let's use the same technique. So tan x is sine x over cos x. That's cos cubed. Okay, I can cancel one of those coses with one of those coses. And then I've got sine and I've got cos squared. If I change the cos squared into sine, or a 1 minus sine squared, then at least everything's in terms of sine, which is quite simple. So that's 1 minus sine squared. And then let's just times that out to make it look a bit nicer. And then I'll leave it as that. I mean, those two are as simple as each other, really. Although it does look a bit BTEC to put a times there. That looks better. Okay. Last example of this type. Cos x. 2 cos x minus 3 tan x. Okay, should I times this out? What do you think? I feel like timesing it out. Okay, I could change that into sine squared, but let me not do that yet, in case I prefer to keep them as coses. I should change that tan though. 3 cos x sine x over cos x. Okay, so that can cancel with that. Okay, then I should definitely change that into sine, because that way it all matches. So I change that into a 1 minus sine squared. And let's just tidy that up a bit. 2 minus 2 sine squared x minus 3 sine x. And that's as simple as it needs to be. You know, I feel like I could factorise that because it's kind of like a quadratic. What do you think? Should we try that? Just for fun? Let's try and factorise that. I don't like the fact that it's negative here, but that's fine. I'll just put the negative on the outside of everything so it doesn't annoy me. I don't know if this will factorise, by the way. And don't say you can make it positive by timesing everything by -1, because this doesn't equal 0. Like, it doesn't equal anything, it's just an expression. So I can't say I'm going to times both sides by -1 because it doesn't have another side, so you're not allowed to do that. So I'll just keep the minus over here. Right, let's think. 2 sine x, sine x. So it's like a quadratic, but instead of x, it's sine x. Yeah, so it's 2, you could think of this as a bit like 2x squared plus 3x minus 2. But instead of x, it's sine x. So is this going to work? Times to make -2. Yeah, it will work. If I put a 2 here and a 1 here, that's going to make 4, and that's going to make 1, and I need 3. So if I do plus 4, take away 1, yeah, that's going to work. And then I could either leave the minus on the outside, or I could put the minus into one of the 2 brackets and negate everything. So I'm tempted to do that with the first bracket just because it already has a negative in it. So I could make this bit negative and this bit positive and swap them around just for aesthetics. And then that would be my answer. That looks quite nice and simple. I mean, the quadratic looks fine, I guess. I'm just being extra. Okay, cool. Next type of question. Solving. So let's solve this equation. Sine theta equals 2 cos theta. Oh, I've got a message. Oh my gosh. Okay, right, sorry, I'm getting distracted. So let's see. Alright, I'm thinking if I divide both sides by cos, that's quite handy because sine over cos is tan. If tan theta equals 2, then to get theta I just need to inverse tan the 2. Which is 63.4-ish, 3SF. Okay, and then of course there are more values. Let's see, 63.4, 180 plus 63.4, 243. I didn't specify what range we're going to solve it in. Let's pretend it is up to 360. So is there any more? No, because where's 360? 90, 180, 270, 360 goes to there. So yeah, there's no others. Okay, next example. 2 sine theta plus cos theta equals 0. I feel like I could kind of make it similar to that. If I take away cos from both sides, then it's basically the same as that. I can divide both sides by cos, and then I have a tan. Well, I have a 2 tan. I have a tan. That's something I've never said. Hashtag white for life. Okay, so tan theta equals -1/2, and then I can just inverse tan that. so theta is minus 26.6. That's no good, I'm not allowed a negative. That's like down there. Minus 26.6. So if I go from, what's that, 90, 180. If I do 180 take away 26.6, that should give me that one. And will there be any others? Yeah, here, if I do 360 take away 26.6. In fact, I should actually not include that one because it's not in the range. So I'll just write no. I'm not going to cross it out or anything because it's part of my working out. Okay. Next one. I've got two more. We may as well do them. Root 3 tan theta equals 2 sine theta. Okay, so this is different. Let me change the tan theta into a sine theta over cos theta. Just because. I've got sine on both sides. I'm really tempted to divide both sides by sine theta. Should I do that? Yeah. Okay, and then times by cos theta and divide by 2. Okay, so I don't even need a calculator for that. That is quite obviously 30 degrees. Or, let's quickly draw a cos graph. 30, what's there, 90, 180, 270, so it's going to be 300. I'm just thinking, and there's something dodgy that I did here, and I don't feel right about it. I divided both sides by sine theta. There's actually a slight problem with doing that. I mean, if you think about it, and I should go back and check the others as well, because I did. It's kind of dodgy too. I mean, when I've divided both sides by sine theta, like, what if sine theta had been equal to 0? Like, then I'll have divided something by 0, and you're really, really not allowed to do that. Dividing something by 0 is, you know, as haram as we know, and it's just not allowed in maths. So, but if sine theta was 0, what would theta be? Theta would be 0, right? Or 360. Would 0 and 360 work here? Well, what's tan of 0? Is 0. And sine of 0 is 0, so 0 equals 0. So yeah, theta equals 0 is a valid solution. And 360 would be as well, right? Because tan of 360 is also 0. Yeah, and sine of 360 is 0. So actually, there's two extra solutions that I did not take into account. There's 4 solutions here. All because when I divided by sine theta, I lost the fact that theta could have been 0 or 360. So you have to be careful. Whenever you divide by a sine theta or a cos theta or a tan theta, you have to ask yourself, could it be 0? And if it could be 0, what would theta be? Okay, so there's actually 4 solutions there. Let me just look at this cos one here. Oh, I got a pen on my table. Oh, that's fine. Where did I... So here, I divided both sides by cos. Now, I have to ask myself, is that allowed? Could cos theta have been 0? Well, if cos theta had been 0, then what would that have made theta? Cos, what does cos look like? That would have meant that theta would have been 90 or 270. But if theta was 90 or 270, then sine theta would have been like 1 or minus 1. And 1 or minus 1 does not equal 0. So this equation wouldn't have worked if cos theta had been 0, because then I would have had 0 on this side, but I wouldn't have 0 on this side. So I'm allowed to divide both sides by cos here, because I know that there's no way that cos theta in this situation equals 0. So that's fine. Have I done Is this only the second solving one I did? Oh no, there's another one here. This one here. So here I divided by cos theta. But again, that's okay, because there's no way that this could equal 0 at the same time that this equals 0. Because cos and sine don't equal 0 at the same time. So there's no way that this side of the equation could be 0 and this side of the equation could be 0 at the same time. So dividing by cos theta is allowed in this case. It's only dodgy in this one, because when I divide by sine, I could get 0 or 360. So what would have been better here would have been to say, instead of dividing by sine, let's times both sides by cos theta. And then let's make it equal to 0. And let's actually factorise the sine theta out of both things, because it's a common factor, yeah? So then you can see we actually have two solutions. We have that sine theta equals 0, in which case theta equals 0 or 360. Or we have that 2 cos theta equals root 3, in which case cos theta equals root 3 over 2, so theta is 30 or 300. Yeah, that's the correct way of doing it. Yeah, that's how I should have done it, and I apologise for being so... I guess I was just taking a shortcut. Okay, let's do 2 more, why not? Root 3 tan theta equals 2 sine theta. Wait, that's literally the one I just did. 4 cos theta. By the way, if you're wondering where I'm getting these questions from, they're actually from the Further Maths GCSE textbook. So if you think this looks familiar, I set this as homework a few months ago. Right, let's change that tan into a sine over cos. Okay, let's cancel those out then. So that's just 4 sine theta equals 1. Okay, so I need to get sine theta by itself, so I'll divide by 4. And then I just need to inverse sine a quarter, which I don't know off the top of my head. 14.47, okay, we'll just say that. By the way, 3SF is usually good for angles. Okay, and then I need a quick sine graph. 14.5, okay, so that's going to be 180 take away 14.5. 165.5, and it's going to, well, that's it, isn't it? I was going to say, oh, and there's one down here, but no, that's negative. I only want the positive. So, those are my 2 answers for that one. Okay, cool, hope that was helpful. Hope it didn't confuse you too much with the dividing by 0 thing. You just watch this video 20 times and maybe it'll make sense. And, you know, you'll get my ad revenue up by doing that. I'm joking, I don't even have adverts, I'm talking a load of rubbish. Okay, yeah, and if you're still stuck, come see me after school tomorrow. And, yeah, I'll see you in lessons on Thursday.